Oh, yay. Okay. I think it's working now. Wonderful. So I've been trying to reach you about your car's extended warranty. If anyone's interested in renewing, do please reach out. So no, more seriously, I'm going to talk about tools for assisted Spark migrations. This is something that I'm passionate about, mostly because I don't want to have to backport patches anymore. For those of us who work on Spark at companies that perhaps move a bit slower than the community, we may get to spend some of our quality time backporting code, and that's part of why people have to pay me money. Also, the timer is not going down, but that's fine. That's fine. I'll just use this time for free. And so it's good. It's good. And like a good software engineer, I try and automate myself out of a job so I can find a more interesting job. Oh no, that's okay. Anyway, so frankly, no one really likes legacy code. At the end of the day, one of my nightmares is waking up in the basement of a bank to the sound of a Motorola pager going off. Anyone here work for Amazon back when they still gave out Motorola pagers? No? Okay, you're all very lucky folk. Anyways, and the sound of a Motorola pager scares me to this day. But by working together, we can get people off of Spark 1.6 and Spark 2.1 and Spark 2.3 and Spark 2.4 and so on and so forth. And then we can eventually have a happy life where we get to spend our time writing new software instead of trying to remember what the insert word here we did 5 years ago. And so the adventure ahead, we're going to go on a super fun adventure. You're going to meet me, the narrator, also Boo. This is specifically Unicorn Boo. I also have, come on. No, Unicorn. There we go. I also have little unicorn things going on. It's good. And our goal today is to save ourselves from legacy software. And I don't want to say our enemy, but our challenge is perhaps that some of our valued partners don't like to wake up in the morning and migrate their code either. And so we're going to solve this like any good software engineer solves any social problem by writing software. And pro tip, it's not actually going to fix the problem, but it might make it a little better. And we will triumph in the traditional fashion of scoping down our original goal enough that it becomes indistinguishable from what we set out to accomplish, but we can still write it up as a success when it comes to review time. Okay, so I'm Holden. My pronouns are she or her. It's tattooed on my wrist. The tattoo got a little messed up after I got hit by a car, but it's still there. You can still read it. It's useful in the mornings. And I am on the Spark PMC. It's kind of like being a committer, but with tenure, except for the cool part of tenure where you get paid. So it's just really hard to get rid of me, but I can still just like make no money. And because this is America, lose health insurance and then, yeah, bad things. It's okay though, I have Canadian citizenship. I can move back. And I contribute to a bunch of other projects too, all kinds of fun. I'll try and sell you my books. You should buy several copies. High Performance Spark is the one that I make the most money on, so I recommend several copies of High Performance Spark. Yes, it is out of date, but that should not stop you from purchasing it. You can also follow me on Twitter, SlideShare. I do live streams. If you've ever said to yourself, open source seems so glamorous, you can watch my YouTube to discover, no, it's not. You can see me on GitHub to see like, yeah, I screw up a lot. And in case you haven't guessed, I do not necessarily speak for my employer. Glorious employer, of course, Netflix is hiring, and I am presenting from their laptop, which means given that I was able to get onto the VPN this morning, I have not been fired. We will see if my VPN connection shuts off at some point during this talk, at which point I will upload my resume to Twitter. But more seriously, actually not seriously either, but one of the things that I also think is important to talk about besides sort of who I am professionally is who I am outside of writing software. Like I'm trans, I'm queer, I'm Canadian, in America, on a green card, thankfully, and part of the broader leather community. And so these things matter, and I think maybe, especially with what's happened recently, we've maybe seen what happens when decisions are made by people who don't have, how shall we say this, a broad social context of views. And I think for those of us who are making machine learning or data-driven things, we have a lot of power, and we can improve or make things worse really drastically. And there are meetings I've been in where people have been like, yeah, we'll just put the location on this for everything. And I'm like, ooh, no one else is gonna say that. Okay, yeah, no, let's not do that. And I think it's important for us to look around on our teams and say like, hey, did everyone go to the same school here? Is, everyone the same gender here? Like, are we all from the same background? And if that's the case, like, let's try and broaden our team a little bit and get some different perspectives. And I think this is important both in our companies and in open source. So please do that. Cool. So this is Spark Summit. So I'm guessing most of you are using Spark. Raise your hand if you're not using Spark. Okay, cool. We're good. Okay, keep your hand, okay, so raise your hand up if you're using Spark before 3.0 in your company, anywhere. Okay, cool. Keep your hand up if you're using a Spark version prior to 2.4, so like 2.3. Okay, that means there's not a lot of Netflix employees here, but that's cool. Okay, cool. Well, I'm glad there's some people. It seems like mostly 2.4 plus, so we won't spend a lot of time on 2.1, 2.2, and 2.3. But if you've ever said to yourself, you know what, Holden, I really want to migrate Spark 2.1 to 3.2, come talk to me afterwards, because we are hiring. But yeah, so we have a problem, and we're going to fix it with computers. And there's some downsides of fixing these problems with computers. And Steve Yegge said something around this. In the context of one of past former glorious employers, with the context of Google. Who here loves deprecated APIs? Okay, just me. But essentially, they made some tools that made it so easy to migrate code that they just, deprecated APIs and migrated things all the time. And then they forgot that those of us outside of Google don't have those tools. And so it turns out that like there are some pain that we're gonna have, but we can mitigate it, and it's gonna be great. So what are the open source alternatives that we could use? Because we don't work at Google, we don't have access to Grok. What can we do to try and make our code work without like having to do that whole thing where we actually do our jobs, right? So ScalaFix is the Scala option. Python, for a language which has only one way to do things, has a surprisingly large number of tools that do the same thing, but that's okay. We've got a whole bunch of different ways to modernize Python code. Go has GoFix, and if you happen to be working in F#, like someone I talked to yesterday with Spark, there's SourceGraph. SourceGraph can also be used to do AST transformations on Java code and stuff. All kinds of fun. So there's open source alternatives to the stuff that Google uses internally, so we'll go ahead and go down that adventure. Most of these are created to upgrade language versions, but just because a tool is used for something most of the time doesn't mean that we cannot misapply it for our own purposes, right? That's how I got started writing Perl software. And so we're gonna go ahead and we're gonna misapply these tools and make Spark work better, maybe. So the TLDR with Spark it's kind of similar, upgrading Spark to upgrading language versions. We deprecate a lot of things. We promise binary compatibility, but fail to deliver. And everything that's labeled experimental is more or less just like YOLO, what's up? And I say this as someone who has written a lot of experimental APIs and then been like, fuck it, damn it. Fudge it. We'll fix it, we'll fix it. It's later, okay, cool. So how can we write our fun tools, right? So it turns out that like writing symbol matchers to do AST transformations on Scala code is actually nowhere near as painful as you might think, right? Anyone here take a compilers class in university or similar? Okay, cool. How many of you still want to write compilers? Yeah, okay, cool. Same. I wrote an algo compiler. It was a bad idea. But we don't have to write our compiler. Someone else, the original compiler authors, already have tools to give us the abstract syntax trees, and then we can write really, really janky rules that apply to these abstract syntax trees. And these rules are slightly better than regular expressions, to be clear. I'm not saying like a lot better, but like it can tell the difference between data frame reader that's imported from, Org Apache Spark SQL and a data frame reader or like a reference to a pandas data frame, right? Because they are different, but like they might have the same textual name if you were just looking at things, and we might not be able to tell the difference if we didn't have the AST. So the nice thing is we can write these matcher rules and they will do the right thing most of the time. Yeah. So here we have we deprecated some fun things in how we did data sets, and so we go ahead and we take our data frame reader, and this is specifically, I think it's where it's taking RDD of strings, and we're just going ahead and converting it into a data frame. And so we also need to specify the encoder of string type, and then if the encoder's import isn't present, we also need to add that. And this looks really cool. Add import if not present. That's some janky stuff that I wrote, because there is a built-in tool in ScalaFix that's supposed to do this, but as far as I can tell, it does not work. It just consistently re-adds the import every time the rule is evaluated, so you get like 5 copies of it. So that's great. It's cool. ScalaFix needs to run on ScalaFix. Anyways, it's cool. Okay. And then, if you remember abstract syntax trees, we end up writing a recursive definition. If you don't remember abstract syntax trees, that's okay. You are probably a happier person than I am. Just think you're writing some recursive code, and you just need to recurse down in the base case where you're not matching anything, and life is happy. And if you're like, I don't know what you're talking about, Holden, just copy and paste the example and change it a little bit. That always works. Okay, cool. So maybe you're like, Holden, that's great. Actually, wait, how many people here use Python? Oh yeah, Python friends, cool. So much fun. Sorry about the out-of-memory exceptions. We're working on it. But so the good news is that we have similar tools for Python, and once again, they are slightly better than regular expressions. They're not quite as good because Python is not have quite as much type information as Scala. So we have we can migrate function names rather than applying regular expressions, but we don't know for sure. I can't tell the difference between 2 degrees called on, say, a pandas data frame and 2 degrees called on a Spark data frame. So this will screw up your code, but it's okay because we turned interactive off, so you won't know. But more seriously, if you do have like a mixture of different data frames, like if you've got pandas data frames and Spark data frames, you can set interactive to true, and then what will happen is it'll ask you hey, what's up? This is the thing that I'm thinking about doing here. Should I do this? And then you can go yes or no, and you can be like a really, really expensive compiler, and that's super useful. Cool. So do types help? Yeah, they totally do, and it would be really, really great if we had more typing information in PySpark. And there is more typing information available in PySpark now. It's super amazing. The sad thing is these tools don't use it. So while the types are there, the tools don't have any idea as to what's going on. So you get to be that human compiler. So that's all kinds of fun. Yay, I'm sorry. Okay, so maybe you said to yourself, Holden, this sounds weird. What does it look like? Okay. And that's what we're going to do. We're going to go look at what this looks like. So I maintain Spark Testing Base. It is a really janky library, but I like it. And we can see here my different attempts at upgrading it to Spark 3. But because, as any good software engineer, I'm lazy, and so instead of spending 1 hour doing it, I spent several weeks working on the tools to avoid that 1 hour of work. And this is what we got, right? Yay! Ooh. Okay, ignore the shell scripts and the release notes. This is the part where we bring in my very high quality 0.1.0 snapshot. Only the freshest bits. And this is where I gave up on Scala 2.11. Sorry. And then we keep going, and we'll get to source code eventually. Yeah, okay, cool. So a lot of these changes are also ScalaFix has built-in fixes that are unrelated to the Spark migration. So it started adding like explicit return types. So if I stopped putting those in at some point, or if I changed the return type of something, the compiler would yell at me instead. But we can see here we've got, let's find something fun. This would have been better if I found the fun thing beforehand. But I assure you there's something fun in here. We will just have to go on an adventure. Oh, maybe it's better. Here, let's go back. Yeah. We're gonna click on one of the specific commits. So okay, I mean this is kind of jank, but it is nice, right? So it replaces the new SQL context call with a Spark session builder, get or create, and then it gets the SQL context underneath because it turns out that I'm lazy and the API on SQL context and Spark session are not quite the same, and I didn't want to change it. But it does enough because we switched from using this constructor, which doesn't work anymore, to the new proper constructor, right? And if we go back, we can see like, because I was writing these rules as we went, oh, right, then after the first time I did it, I was like, oh, I forgot to put the imports in, so my code didn't compile, so then I added the thing to do it where it adds these imports automatically. As you can see, it adds it with kind of crappy Scala style, so I probably should have fixed the Scala style, but see my previous reference about being lazy. Okay, cool. So that's great. We've got a bunch of rules. We can run them. I did run them. They worked well enough, and then it's great, and you can add more rules. So, cool. We could go skim the rules, and we might return there if we've got time, but I wanna go ahead and talk about some other things that are also fun related to this, right? Because you might be going, Holden, these automated upgrade tools sound amazing, but like, you know, what doesn't work? So dependencies don't really work. If anyone's stuck on Elasticsearch, you should move to the open source fork of Elasticsearch. Sorry for those of you who work at Elastic. It's great. The Elasticsearch connector was the #1 blockier reason that I found for people. The other thing is there's a lot of really old Scala code out there, and unfortunately, the Scala fix tool does not understand the Scala AST of Scala 2.10. So this will not help you. I'm very sorry. But that's okay. That's okay. That's why you have a job. That's okay. So Python language versions, also something that is fun. You'll need to migrate off of Python 2. If you haven't already, please do. But the good thing is there are actually lots of tools to migrate Python 2 to 3. While it may make you sad, it's totally doable, and these tools will help. But the other thing is, like, let's say we run these tools, how do we know if we like screwed up, right? Do we know if our pipelines are the same, right? And this is a very reasonable question, one of which I normally go, but it turns out that like hope is not a plan, as my boss said to me when I was like, it'll probably work. She was like, not good enough. And this is an area of improvement, Holden. Other things like this, right? So one thing that we can do is we can get people to write tests. How many people have tests for their data pipelines? Okay, keep your hands up if you're confident those tests will catch errors, including switching Spark versions. Okay, cool. Is there anyone with their hand still up? Okay, like one person, half a hand, great. So, okay, so we should definitely have tests, and I'm not saying we shouldn't, but they're probably not enough, right? We probably need to do some more validation beyond just like seeing that our unit tests pass, right? And so there's a whole bunch of different things that we can do. And I was hanging out with the wonderful LakeFS folks earlier in the week and decided to make a demo using LakeFS so that we could see if our upgraded pipelines work or not. Also, because of what I do for that thing where I receive money, I also tried to make it work with Iceberg, but it turns out that part's kind of annoying, and I was trying to fix it at 9 a.m., but notably it's 9:35, and I probably didn't fix it while we were talking. Yeah, okay, so it doesn't work in Iceberg just yet. I'll totally fix it for Iceberg eventually, especially if you work at Netflix. I promise the software will work for us eventually. But For LakeFS, we have this very high quality script called domagic.py, and that's how you know that this is truly some of the highest quality software that I have written in the past 24 hours. And so our input table is fartsmcgee, and my repo name is myrepo. And we're comparing the pipeline ls and the other pipeline ls. Okay, so this is admittedly somewhat contrived, but I actually wanted it to be able to run on my laptop without having to do anything. Okay, so blue. This did a bunch of magic. Now it's doing some stuff. Let's go look at the code. Well, let's wait for it to finish comparing these two output tables really quickly, and then I'll walk us through the code. But actually, yeah, maybe I'll walk us through the code while the pipeline's blocked. Let's do that. So this high quality domagic.py file, which is definitely not good code. Don't run this in production unless you're interested in, I guess, making it really hard to replace yourself, in which case do run this in production, because no one else will understand what you're doing yet. So the only code path that works right now is the LakeFS code path. The Iceberg code path is a work in progress. This loads the configuration. What it does is it goes ahead and it makes some branches of your data, conceptually very similar to Git branches. Under the hood, there's an implementation details talk about LakeFS. I want to say at like 10? 10, yeah, okay, at 10. So session right after this in a different room, they'll be talking about how LakeFS works under the hood. But really what this does is this goes ahead and it creates 3 branches. The reason it does this is so that if someone does commit to the main branch while we're making like 2 different branches, we don't have like a race condition. So we make a first branch and then we make 2 child branches from that branch. And then we go ahead and we run our pipelines and we check that the pipelines actually run. And then we commit the results on these branches. These are committed to branches, so they're not going to production. And then what we do is we go ahead and we run another very high quality Python script called table_compare.py, which compares all of the tables that we had listed as our output tables between these 2 branches and asserts that they're the same. Now, if you've played with LakeFS, you've seen that LakeFS does have a built-in diff thing. This doesn't use that because when you're upgrading Spark versions, LakeFS is very binary focused, and our Parquet writers do change slightly between versions, especially things like compression and the headers change, and so it would show a diff in the case of doing an upgrade. So we actually want to look at the data inside of the files rather than just looking like, are these files binarily equivalent? We want to know, like, are the rows the same? Because really that's all I care about. And you'll note, like, I have many to-dos in this, like any good conference software. And yeah, then finally what we do is we go through and we delete all the branches unless you told us, like, no, I want to keep the branches around to take a look and see if it's different. And then down here we have our high-quality Iceberg code, which does not work, but probably will by next week. Not a promise. If you're my boss, it'll work eventually. But the Iceberg code works conceptually similarly. What it does is it snapshots all of the input tables, runs the pipelines on these snapshots, creates temporary tables, compares the temporary tables' outputs, cleans up those temporary tables, and moves forward. The difference is it has to snapshot each table individually, and it's a little more annoying if you had a pipeline which is trying to do like an upsert. It doesn't have a good way to handle upserts just because we use a create table like, and we don't have a like easy way to like branch a table in the same sort of conceptual fashion as you do in LakeFS. And we have the same high quality async Python code that totally probably works. Except for the part where it doesn't. Okay, cool. And another option, of course, is if you're like, Holden, that sounds great and all, but like, I've got some weird things going on. I don't actually expect the data to be output between 2 separate runs of my pipeline on the same input to be the same. I would say to you like please like choose a random seed or parameterize your inputs in a way that you can make your pipelines at the very least comparable. Failing that, you can write validation queries. The SOTA-CL folks who are here as well are awesome. They open sourced their validation query stuff, very similar to some internal things that we use that do validation queries. So you can write things like, hey, I expect the number of rows that are output to be greater than 0, or other sort of advanced debugging techniques like this. Or like, I expect the number of rows to be output to be less than the number of rows that were input. For example, like we might be filtering customers out for fraud, and if we end up with more customers after we filtered out our fraudulent customers, that might be a sign that something has gone wrong, right? And SOTA-CL gives you a way to express that. But really, use whatever tool you want, and you will see if it works or not. It'll be great. Let's see if the demo finished or if it crashed. Cool, it finished. Let's go echo $? Cool, exit code 0, great success. You can tell I am for sure a UI developer. Exit code 0 means no problems. Please ignore everything that's printed to the screen. Great, okay, cool. So in conclusion, the good news is we haven't made a system so powerful that we can change our APIs all the time. That's, it's good. The bad news is that we haven't made a system so powerful we can change our APIs all the time, because it turns out that we're still doing it anyways. The most excellent news is that my dog is adorable. This is Professor Timbit. I love Professor Timbit more than I like Spark. He's much cooler. He does smell a lot more like fish, though. Okay, let's see here. What else? Okay, yeah. And so I do have a little bit of time to tell you about distributed computing for kids. And so I'm going to do that for a little bit. But I would love to know how many people have questions so I tell you the right amount about distributed computing for kids. Okay, there's like 2 questions, maybe. Okay, I'm going to do distributed computing for kids. We'll circle back, and if there's just 2 questions, we'll have time. So, distributed computing for kids is an exciting way to introduce children to our nightmare world of out-of-memory exceptions. So Alex and Ziva are friends, and for some reason, they want to analyze some data. Namely, they want to find popular tags on Instagram, because that's my understanding of what kids do these days. I am probably pretty out of touch with the kids these days, but as far as I can tell, children like Instagram and garden gnomes. So that's totally going to happen. It's going to be great. Our garden gnome friends offer to help them find what the popular tags are on Instagram amongst their friends in exchange for some tea, because I'm now green card holder, everything must be a commercial transaction. That was a joke, but okay. Anyways, so the gnomes all download Instagram. While it installs, Alex and Ziva write down a list of their friends' Instagram accounts. They do this on a stack of cards so that we can split it up really easily. Here we can see them like looking at their cards. They're brewing some tea for the garden gnomes. It'll be great, all kinds of fun. And then it's time for the gnomes to get to work. And just like any project in Freedom Land, we have a manager. And so we decide that the leader is going to be one person rather than operating by consensus, because we want to be able to do things quickly. And other reasons. And so our leader is going to look at the stacks of cards to guess how many, cards each garden gnome should get to figure it out. And we try and assign the work equally-ish, but that doesn't work super well, right? We might end up with one garden gnome who is kind of a straggler. Maybe they get too many index cards, and so they're just like, ugh, this is taking too long. I want my tea. And, they stop working. Yeah, and so the garden gnomes start, they've got their list of Instagram handles to look at. They start writing down what the tags are that they're seeing from all of these different posts. So we've got best dog and coffee. Those are the only 2 things that I really care about at 9 o'clock in the morning. Oh, and SIG scheduling, whatever. Sorry. And because they're garden gnomes, they're working on top of toadstools and underneath toadstools, and they're drinking tea. And now they're going to go ahead and figure out the tag counts. But now we're down to 5 minutes. And so if you want the rest of it, you should definitely go to distributedcomputingforkids.com. And let me go back here. Distributedcomputingforkids.com. I really need to update the graphic because we still have the old scary garden gnomes on it that look like they're doing acid. I assure you the children's book will have less drug references. And you should give me your email address so that I can try and sell you this book. But let's take the questions now, either about distributed computing for kids or upgrading Spark versions. I think you had a question, right? Oh, there's a microphone coming your way.
There's an earlier slide that showed that there's a lot of Scala 2.11 code out there, but it said our resources are focused on 2.12 to 2.13.
Yeah.
So if we're on 2.11 right now and we eventually want to go to 2.13, would you suggest going from 2.11 to 2.12 first and then going from 2.12 to 2.13, or just to do it in one step? Thank you.
That's a really good question. Do you like your coworkers? Okay, cool. So in that case, I would say, well, there are tools to go from Scala 2.12 to 2.13. It's probably better to just do it in one step. Just go straight to 2.13. So some of the downsides of that are like not all of the libraries are like a super happy fun times on 2.13 yet. So take a look at the libraries, and if all of the libraries you want are already available on 2.13, go for that today and save yourself a headache. On the other hand, if there are libraries that you want that aren't yet like working well on 2.13, 2.12 is a great place to hang out for a while and have a party. Cool, we got like 2 minutes and 55 seconds for another question. All right, cool. Well, thanks everyone for coming. I really appreciate it. I am probably fairly easy to find at the conference, so feel free to come by and ask me your questions. You should definitely check out the next talk at 10 about the LakeFS internals. And if you are interested in working for Most Glorious Employer, please come and say hi. We are hiring despite the layoffs.